So welcome to part 2. So I said I'd explain exactly what is Pythagoras' theorem. And basically what you've learnt from that puzzle that you solved is that in a right angle, this only works in a right angle triangle, okay? If you make a square from one of the smaller sides and a square from the other smaller side of the right angle triangle, you can add up the areas of those squares, so add them up, and that will be exactly the same as the area of the square of the larger side of the right angled triangle. Okay, so area A plus area B is going to be equal to area C, okay, where C is always the longer length. Okay, so this one has a side length A, this one has a side length B, and this one is C, where C is always the longest length. Basically the one that's opposite the right angle. The one that's opposite the right angle, okay? So Pythagoras said for any right triangle, the sum of the areas of the two small squares is equal to the area of the larger. And so what that does, it gives us this equation here. A squared plus B squared is equal to C squared, where C is the longest, the length of the longest side of the right angled triangle. Now C has a special name. I expect you to remember this name, okay? C is the hypotenuse. The hypotenuse. The hypotenuse is the longest side of a right angled triangle, okay? The hypotenuse. I expect you to remember that word. Okay, so that is what Pythagoras worked out. And actually that puzzles that you did was some of the proofs that exist for Pythagoras' theorem. Okay, so let's have a look at how this works in a practical sense. Okay, let's look at this green triangle on the left. Now what we know is that we've got a right angled triangle. We've got one of the small lengths is 3 and one of the small lengths is 4, and we don't know the longer length. So I'm going to call the longer length x, okay? Now, we always have the equation for Pythagoras' theorem. Pythagoras said a squared plus b squared equals c squared, where a and b are the shorter sides and c is the longer side. So we can easily make an equation that says 4 squared plus 3 squared equals x squared. Okay, now you probably understand why I gave you the starter questions that I gave you. It's a very simple equation to solve. Let's actually turn it around. So x squared equals 4 squared plus 3 squared. X squared equals 16 plus 9. Okay, I'm just going to move over here. X squared equals 25. But I don't want to know x squared. I want to know x. So what do? I square root both sides of the equation. So x is equal to 5. Okay, so I know this length must have been 5 centimeters. Okay, let's do another question. Let's do that red one. Okay, so again we've got the two shorter sides and we don't know the longer side, and it's a right angled triangle. Has to be a right angled triangle. So we're going to go and say that x squared is my longer side is equal to the sum of the squares of the two short sides. Okay, so x squared is equal to 49 plus 81. So x squared is equal to, what's that? That's 130, I think, isn't it? Yeah, 130. Now 130 is not a square number, so that is difficult to square root, because we need to do the square root of 130. So you'll use a calculator. The square root of 130, and we're being asked to give 2 decimal places. So according to my calculator, that is 11.40 centimeters to 2 decimal places. Okay? So sometimes the length of your side might be a nasty little number, and you just have to round it off. Okay? So let's get rid of that. Now, you've got to be really careful with the blue ones, okay? We're still using the same formula here because it's Pythagoras' theorem. We've got a right-angled triangle and we know two of the sides and we want to find the third side. But this time, you actually know the long length. What you don't know is one of the shorter lengths, okay? So you need to do we'll call that one x. You still use the same equation, okay? The short side squared plus the other short side squared is equal to the long side squared, okay? So that's still just using this equation here in exactly the same way, but now you've got a little bit of extra work to do to solve that equation. What you'll do is you'll take away 5 squared from both sides, and you will see that x squared equals 13 squared minus 5 squared. Now, putting that directly into my calculator, I will see that x squared is equal to 144. You can either use a calculator or recognise that that is a square number, 144. It's actually 12 squared. So when we square root both sides, we're going to find out that x is equal to 12. Okay? So we can also use Pythagoras to find the shorter sides, not just the long side. Okay? Just have to understand how to solve equations properly. You are getting better at that, so that's good. Okay? So what about the yellow one? Well, that's the same thing. We're finding a short side, not a long side. So we're going to say x squared plus 5 squared equals the long side, which is 10 squared. It's always the same. Okay, now we've just got to solve that equation. So let's take away 5 squared from both sides. So x squared is equal to, well, it's going to be 100. It's going to be 75, isn't it? 10 squared is 100, minus 5 squared, 25. 100 minus 25 is 75. 75 is not a square number, so when you square root, you're going to have to use a calculator. Okay, and I know that the square root of 75 is equal to 8.66 centimetres to 2 decimal places, just rounding off there. Okay, so you can find missing lengths of right-angled triangles by using Pythagoras' theorem. You can find longer sides and you can find shorter sides, and you recognise that sometimes it's a nasty number, and so you're going to have to use a calculator to find it. Okay? Right, so obviously what I want you to do now is do a little bit of practice. Oops. Okay, let's just check that you understand this then first. So what do you think is the correct calculation to find the missing side for this one? Is it A or is it B? Well, hopefully you went for A, because we're finding a long side. So you should have said x squared is equal to 8 squared plus 6 squared, and then square root both sides. So x is equal to the square root of 8 squared plus 6 squared. Okay. What about this one? Is it A or is it B? This one definitely should be B, because you should say that x squared plus 6 squared equals 11 squared, because 11 is the longer side. So x squared equals 11 squared minus 6 squared, and so x is the square root of 11 squared minus 6 squared. Okay? So hopefully you understood that. Right, okay. 4 questions for you to have a go at, okay? You can use a calculator if you want to. Okay, stop your video. Make sure you draw the triangles as well. Nice little sketch. And show all your working out. Okay, stop the video and I'll display the answers in a second. Okay, here we go, guys. Here's the answers. Okay, check them. Obviously, if you're getting things wrong, let me know, and I'll try my best to help you understand. Okay. Okay, again, stop the video, have a go. Oh, sorry, but probably better explain this question. This was slightly different. So this time you've got all three sides of the triangle. What you need to do is to discover whether these are actually right-angled triangles or not. Now, if they are a right-angled triangle, they will conform to Pythagoras' rule. If they're not a right-angled triangle, they won't conform to the rule. So you would find that a squared plus b squared does not equal c squared. If that's the case, it's not a right-angled triangle. So see if you can determine whether each of these right-angled triangles are right-angled or not. Okay, so stop your video and have a go now. Okay, A is a right-angled triangle. B is a right-angled triangle. C is not a right-angled triangle. And D is a right-angled triangle. Let's just look at C. C, we'd be looking at this. 46 squared plus 29 squared is equal to 54 squared. So I'm going to use a calculator. 46 squared plus 29 squared is equal to 2957. And 54 squared is equal to 2916. So the two are not equal, so it could not be a right-angled triangle. Okay, stop your video and have a go. This time back to the more traditional questions of finding the length of some missing sides. Okay, hopefully you remember to give your answers to 2 decimal places. So here are the answers. Okay, 13.89, 12.04, 8.60, 11.40. Okay, let me know if anything there's confused you. Okay, another 4 for you to have a go at. Okay, find the missing lengths, giving your answers to 2 decimal places. Okay, here are the answers. Okay, again, let me know if you've got any problems with those. Okay, I think this is the final 4. Stop your video and have a go. Okay, here are the answers. So 48, 56, 80, and 77. Okay, I'm going to stop the video there.